I love that.
All right, so if this is what's given to us based on what we know at this point about simplifying trig expressions, we're going to carry those rules over to this problem. And what we're going to do is we're going to pick one side of the equation to work with exclusively and try to make that side look like the other side. That's the rules we have to follow when we're verifying. We can't mix and match sides, okay? We can only work exclusively with one. So as I divide this up, and I look at which side would be a better side to work with. Sometimes it's more obvious than others, but best rule to follow is pick the side that looks like it's got the most stuff to play with. Obviously, that would be this side. If you think of how you simplify a trig expression, that's basically what you want to do to this side. You want to go through, like we talked about last time. You want to replace anything that is not already in terms of sine and cosine, like secant here. Secant we could write as 1 over cosine of theta. Everything else is already in terms of sine and cosine, so we'll leave that as is. All along we're trying to make this look like the other side, right? As we continue on, following order of operations, might want to work with what we have inside the parentheses here. Might want to consider the fact you got some fractions, and since we're subtracting, we need to find a common denominator, maybe put that stuff together. So if we put all this together, we multiply our denominators, right? We set up one big fraction. Denominator is going to be cosine of theta. Then in the numerators, we do the cross product idea. So 1 times 1 gives me the first term. We're subtracting the cosine times cosine, so that's cosine squared theta, right? In the meantime, we bring down this cosine of theta on the outside. And now that we have a fraction inside the parentheses here, and we know we're multiplying a cosine of theta on, well, I should probably put this cosine of theta over 1. So I can multiply through as 2 fractions. Now, when I multiply all this together and I create one fraction, what you're ultimately trying to do with one fraction is get it in a factored form and try to do some canceling, right? So if I multiply this cosine of theta to this 1 minus cosine squared of theta, the way I would write that, I'd probably write it like this. Whoops. In other words, don't distribute it through. You want a factored form because potentially you can do some canceling within this bigger fraction. In the denominator, you've got 1 times cosine of theta. And now by leaving it in a factored form, notice what happens. The cosine of thetas cancel out, right? And you're at that point in the simplification process where you've done as much simplifying as you can. You've done as much algebra as you can. So now it's time to use identities. As you look at what remains, and keep in mind where you're trying to go over here, I've got a 1, I've got a cosine squared. That's supposed to ring a bell as an identity. What does 1 minus cosine squared equal? Sine squared. So all of this, in the end, simplifies to sine squared of theta, which is exactly what I want because that matches the other side. By doing that, I've verified this identity. All right, so on this problem, as you consider which side to work with, again, we can only work with one side exclusively. A lot of times when we simplify trig expressions, it makes sense to rewrite what we can in terms of sine and cosine. So you might be tempted to work with this side. But I would advise maybe playing with this because it's a couple of fractions. It's a couple of fractions we can put together, and that tends to be a slightly more complicated idea. So really, we got a little more to play with over here on the right side. Okay, that's just my opinion. And that's just the way I see this problem, so that's the way I'm going to go with it. If you want to work with the other side and find a way to split it up so it looks like these two fractions, you know, more power to you. That tends to be a harder road to travel. All right, as I play with the right side, if I'm simplifying the right side, I've got two fractions I'm subtracting, what should I do? Okay, I need to put them together. I need to find a common denominator, right? So create one big fraction. Take your two denominators, multiply those together. If we're consistent with what we've done so far, we're going to leave that in a factored form, at least for the time being. Okay, then we look at the cross products, right? We're taking 1, we're multiplying to that quantity of 1 plus sine of x. Go ahead and distribute the 1 through. Obviously, we get 1 plus sine of x. Now as we do the other cross product, understand you are subtracting this 1, right? So that's going to be a negative 1 that I distribute through to this 1 minus sine of x. Distributing negative 1 through, you get minus 1 and plus sine of x.
Why wouldn't it be minus 1 the first one?
All right, so at this point, we're collecting like terms in the numerator. As you collect like terms, you're going to notice that the 1's cancel out. And we have a couple of sine of x's we can put together. So we put those together. We still got our denominator in the factored form. Now as you look at our result, this is where we've simplified as much as possible. We'd like to incorporate maybe an identity in at this point. We also got to remember where we're trying to go with this. We're trying to turn all of this into 2 secant of x tangent of x. Doesn't seem like we're there, right? Since we left everything in the factored form and nothing's going to cancel out, maybe now, since we're a little bit stuck, we could multiply all this out in the denominator. If you do that, the hope would be that we get something we can play with. So I'm stuck at this point. I've simplified as much as possible. No identities I can use. Go ahead and multiply things out and see what happens. As I FOIL this out, I'm going to get 1 minus sine squared of x, right? Because if I look at the factorization for this difference of 2 squares, it would take me right back here. Did that give me something? Okay. 1 minus sine squared of x is an identity. 1 minus sine squared of x is cosine squared of x. So I have 2 sine of x over cosine squared of x. Can't do much better than that with the simplification, right? Or the identities. But I haven't yet arrived at the other side. So now if I cheat just a little bit and I look at the other side. Remember how I talked about if we were going to play with this other side, it'd be a good idea to write everything in terms of sine and cosine? What if we thought about the other side in terms of sine and cosine? We're not actually going to work with this side. We're just going to consider it, okay? So as I consider the other side in terms of sine and cosine, secant of x is 1 over cosine of x, right? Tangent of x is sine of x over cosine of x. So if that's where I'm going, and this is currently where I'm at, is there a way to break this up so that it looks like this piece? Okay, that is what we have. Because think about what happens when you multiply that out. When you multiply this out, because it'd be 2 over 1 there, you got 2 times 1 times sine, so there's your 2 sine of x. You got 1 times cosine, there's your cosine squared. So it'd be fair at this point to take what I have right here, rewrite it so that it looks like that, because those are equivalent. And then my last step would be take this, transfer over to that idea. It's kind of a backwards thought, but it'll get us there. So I'm going to take this idea, I'm going to break it up. kind of just continuing down the page here. I'm breaking it up to 2 times 1 over cosine times sine over cosine, which in the end gives me 2 secant of x because of the 1 over cosine, tangent of x because of the sine over cosine. That carries us through from the other side, right? I'm working down my page. I'm bringing this idea down, carrying it over here, noting that they're equal, patting myself on the back. All right, we've done a couple of these now. As you consider this problem, you split up the 2 sides. I'm trying to figure out which side to work with exclusively. Which side do you think is a good one to play with? Left side? Okay, left side seems to have some stuff. Right side's just one simple fraction with everything in terms of sine or cosine already. So if you work with the left, what's the first thing we should do?
Oh, I just have a question.
Yeah.
So, like, when you...
Trying to figure out which side to play with. We talked about playing with the left, right? So if we're playing with the left, we're going to change everything over in terms of sine and cosine. With this secant squared, that's going to be 1 over cosine squared of x. Doesn't matter what the power on that. I mean, if we know secant is 1 over cosine, then secant squared, we just include the squared with the cosine part. We're adding on, we've got tangent, which is sine over cosine. And we've got secant again, which we're multiplying. That's 1 over cosine. I'd say if we're just simplifying at this point, it would make sense with all these fractions to go ahead, follow order of operations, and multiply these 2 fractions together. If you multiply those two together, you've got sine of x over the cosine squared. In the meantime, we're bringing down the 1 over cosine squared of x. Got 2 fractions that we're adding. This one's actually nice because we have a common denominator, right?
Yeah.
We can go ahead and put these together. Make this 1 plus sine of x over cosine squared of x. No need to do all that cross product stuff since the denominator is the same. And we've simplified as much as we can. This is where we would use an identity at this point. Any identities come to mind? Okay, cosine squared. We see these cosine squareds. We're supposed to be learning at this point that cosine squared of x equals something. It equals 1 minus sine squared of x. So I'm going to substitute that in. In the meantime, that numerator is just 1 plus sine of x, right? Now considering where I'm trying to go, I'm trying to get this 1 over 1 minus sine of x. I'm getting pretty close. I do have a fraction to play with. And when you have a fraction to play with, if you want to do some further simplifying, you got to make sure everything's factored out. So is there any factoring I can do to this problem? Okay. You got your denominator. That's a difference of 2 squares, right? So since it's a difference of 2 squares, right now, numerator, we're keeping the same, right? But our difference of 2 squares in the denominator factors to 1 minus sine of x times 1 plus sine of x. Once everything is factored out, then you can do some canceling. So the 1 plus sine of x's will disappear. And understand as we cancel, right, technically factors of 1 are left. And that's significant here because that's going to give us the 1 that we need on top over the 1 minus sine of x on the bottom, right? So I've kind of run out of space here, but my next step would be, right, 1 over 1 minus sine of x. Then carry this guy through. You verify that the equation's true. All All right, so here we go. We've got to pick a side, one side exclusively to work with. Which side makes the most sense? Okay, right side. Right side, because of the question we were just talking about, right? You can take all these trig functions, you can write them in terms of sine or cosine. So if I take tangent squared of theta, I write that in terms of sine or cosine. We have sine squared of theta over cosine squared of theta. In the denominator, you've got secant of theta, so that's 1 over cosine of theta, and then minus 1. Now, considering what we talked about yesterday when we simplify the trig expressions, we got these fractions within a fraction, right? We want to get rid of those fractions within a fraction. So we consider these denominators. The denominators on our little mini fractions. And we're supposed to multiply both the numerator and denominator of our bigger fraction by those denominator ideas. Now, in the examples we've talked about up to this point, those denominators have been the same. Obviously, these are different. Since they're both cosines, what you're going to do is you're going to multiply both the top and the bottom by the greater power of the two. That way, we'll be able to cancel out all of these fractions within the greater fraction. So take the greater power. If you multiply by the greater power, in the numerator, I'm taking this cosine squared of theta times sine squared of theta over cosine squared, right? What's supposed to happen? Cosine squareds are supposed to cancel, right? So if the cosine squareds cancel, all you're going to be left with is sine squared of theta. In the denominator, I need to distribute this cosine squared through. That's the only way I'll be able to cancel out this fraction right here. So when I distribute it through, it's a cosine squared of theta over 1, right? Now, when I distribute to the 1 over cosine of theta, it'd be cosine squared times 1 over 1 times cosine, right? So that would leave you with cosine squared of theta over cosine of theta. What does that reduce to? Cosine of theta. So it becomes cosine squared of theta over cosine of theta, reduces down to cosine of theta. When I multiply this cosine squared to the 1, a little bit easier, it's just going to be minus cosine squared of theta. Okay, it's identity time. When it's identity time, we notice things like sine squared of theta. We replace sine squared of theta. What's it equal? 1 minus cosine squared. Good. Should make some sense, too, that if we're trying to go to something like this, and we got cosines over here, as we go along on this side, we're trying to change things over, so we got cosines, right? Now, your denominator. Yes, there is an identity we could use for this cosine squared. It would not make sense to use it, though, because that would put things in terms of sine, right? So we're going to leave the denominator alone. And if anything, since we got this whole fraction idea, maybe we should factor out a cosine. Would that make sense? Right? We got a cosine that is a greatest common factor of both. We're at the point where we got this one fraction to play with. We know factoring is a good idea when you got one fraction to play with. So take out the greatest common factor of cosine of theta. You're left with a 1 minus cosine of theta that trails. Speaking of factoring, any other factoring that we can do? Okay, the top. This numerator is a difference of 2 squares. If we're using all these identities, we're going to encounter these difference of 2 squares quite a bit with all this factoring. So the 1 minus cosine squared of theta becomes 1 minus cosine of theta times 1 plus cosine of theta all over the other factorization. And hey, what do you know? We factored everything out. Stuff starts to cancel. And what are we left with as our final step? We're left with 1 plus cosine of theta over cosine of theta, which is what we got over here. So I'd write out one more step, but again, I've run out of room. So I'll let you guys write.